Okay, everyone, welcome back from the lunch. I hope you all enjoyed the meal and the conversations and networking you were able to do out there. Welcome to track 2, to those of you who haven't been here with us already so far. Here in track 2, we're talking about AI, large language models, and automated text processing, a subject that's very much in the news right now, as me and Chris were outlining at the start of the day. Let me give you a little refresher also in how asking questions works in case you're just tuning in online. So you can ask your questions via Slido, whether you're here in the room or online, but there is a 1 to 2 minute delay on the online feed. So if you're online and you want to ask a question in Slido, try to do it quickly, or else by the time I see your question, we may have actually moved on to the next speaker. If you're here in the room, you can also ask your question live in person. I'll do a scan to see if anybody has a live question. So we're now going to move on to the next section in track 2, which is on AI-driven data interoperability and mapping. So I'd like to introduce our first presentation, which is entitled AI-Enhanced Data Modeling, Harnessing AI Assistance for Semantic Interoperability. And this presentation is by Emilien Caudron, who is AI and semantic developer at PwC in Belgium, and Georges Lobo, who is program manager at the European Commission's Digital Services Department. Gentlemen, I turn the floor over to you.
Hello, thank you for giving me the floor. So I will start, and Emilien will do most of the part of the talk. So I'm Georges, as you mentioned. I'm Georges Lobo. I worked. May I ask who knows CEMIC? Okay, quite a number of people. So I'm the team leader of the CEMIC team in the Digit, in the unit you mentioned. So we have a number of activities that you can see on this slide. Are we projecting the slides or? Okay. Okay, thanks. So, I mean, these are an overview of the activities we do and on AI. So we are doing different things. So I would say, and you will see the presentation later, it's more on interoperability for AI. So it will be the presentation. And we have some, we did some proof of concept and MVPs. And we do pilot project how AI can assist semantic solution and modeling. And we do also a number of studies. And today, Emilien will present a prototype we did on a chatbot generator. Over to you.
Thanks, George. So indeed, for today, what we want to present to you is a proof of concept of assistant chatbot that's supposed to help data modeler. And one of the problem statement or the key question that triggered the whole process of this proof of concept was, if we want to reach better interoperability, one of the things that we need to try to do is not reinventing the wheel. When we are creating a new data model, we should try to see if there is any existing classes, relations, properties that already exist and that we could reuse or adapt in our data model to maximize the chance that we have a data model that's interoperable on a semantic perspective. But if we want to do that, the issue is that there's so many data models, so many standards that are created that for a data model, for semantic models, it's becoming increasingly complex to do it. What you would like to do, and that's what CEMIC wanted to do, is can we not leverage AI, LLMs, to actually recommend classes relationships to a semantic model based on a library or knowledge base of existing standards? And so being able to quickly suggest a possible name for a class, a properties, or a relation. But then the key question we had to answer is, how do we provide this modeling knowledge to the LLM? The approach we decided to take is the one of Retrieval Augmented Generation, so RAG, where we have our basic LLM that has training knowledge, gained from generic data. And then we have a knowledge base containing a set of relevant documents of data models of semantic specifications. And what we will have is that, thanks to a search engine, we'll be able to find the data models, documents that are the most relevant to answer the query of the user, provide it to the LLM, which will then generate a grounded answer. What did we put into this knowledge base for the proof of concept? Well, we are working for CEMIC, so some CEMIC specification were added to this knowledge base, some in HTML, but then we also decided to include some RDF files directly. In our case, some again CEMIC specification, but also schema.org and linked open vocabularies to have something rich that the assistant could rely on. Then once we had this knowledge base, we could have multiple ways of accessing it. So we have HTML sources, but we also have RDF documents. So for the version you're going to see, it's a classical hack. So we took the different documents, we indexed them, and provided via an index search, a vector search approach. Another way could be to directly make the query over the graph, so that you don't lose any information. You can still use the old contextual part that is inside the graph data. This is something we are currently looking at as part of CEMIC, and this could be in the next version. So with that, we were able to have a knowledge base, access it properly, and so the LLM has data modeling knowledge, but we wanted still to integrate the whole tool into the data modeling process to make it easier for data modelers to use it. So we wanted to have a few additional functionalities to be able to upload the model, chat with it, brainstorm about what could be missing, what could be reused, have a search on existing concepts, adapt it, export it, or visualize it quickly. And to have all those different functionality created and available, we decided to rely on MCP, so to create an MCP client where we have an LLM orchestrator that's able to reason over the question of the user, and then looks into an MCP server where we have different tools available, different documentation available, looks inside this and identified which tool it should use to answer the question of the user in the best way possible. Some of the tools that we have is the search reading index, the possibility to modify the data model, visualize it, or read it. And we are currently working on additional tools to make some checks about semantic interoperability or searching directly through a graph. And that's it for the presentation. Let's deep dive directly into a demonstration of the tool. So this is the current UI, where you have the possibility to download your model here under an XML format. And once you have it, as I said, you can simply chat with it. The first question you might ask, you could visualize it, so to have a quick view of the UML, inspect it, see if you already see something missing or an element that you would like to add. But also you can directly do this exploration via chat. So asking about what are the different classes that I have in my model. Then the tool is going to query the MCP, find the data model like you have, and tell you, okay, but these are the different classes I have available with the definitions. It's still a bit vague, so I may want to know a bit more information about one specific class. In this case, I'm going to go for person to have a view about the URI definition, what are the attributes that I already have, the different association I may have, and you see here already a more clear list of what's available. Then what is nice is that you have with this tool directly the capabilities of the LLM, of a GPT-like tool. So you can use it to brainstorm. So if I have a specific use case that I want to tackle, I can ask the LLM to give me some idea. Here, the example, let's say I'm working in a hospital and I want to model a patient. How should I adapt the person class that I have at the moment? Here it's going to look at the class, the different attributes, and say, okay, what are we missing? Going to give you some proposition. Okay, you should have medical information about the patient, so date of birth, gender, blood type, allergies, all that type of information. You could also need administrative or logistical information, consents, contact information. Now, good, I know what I need to add, but is there something already existing to describe some of those attributes? That was one of the key use cases that we wanted. And so here, you can just prompt it to look into the knowledge base to see, is there in LOV or in some semantic specification something that already exists? Here you see it says, okay, I'm going to start looking for all these different elements. And then it calls the tool. That's the nice thing about the MCP that we created, is that you can see exactly what is the query that it did on the knowledge base and what are the results that it could receive. So you can have a high level of transparency on where does the LLM find its information in that case. So here, for example, we have date of birth, gender, sex, and it has found the card ontology that you can use for this as an example. Once you're happy with the element that you want to add, you can directly make the modifications. So here, add those attributes to the model. And you see again, it can call multiple tools to make the modifications. And here, the modification has been made. You can check the arguments. You can check the results with the fact that we have gender added and the different tags, usage notes, URI, definition that are reused from the element found. So that's a basic workflow, but thanks to these reasoning elements that we have on top, we can also start thinking about next steps and more complex queries to answer thanks to this tool. Here, I'm going to take the example of just asking, okay, I have a model, how interoperable is it on the semantic level? And so you see, the tool is planning different steps, defining a set of criteria for evaluating it. And then once he has defined a plan that he believes is correct, he can call the different tools available here. What he is doing is, I'm going to check all the classes and see if I'm properly reusing standard classes that are available. And you see here, for a program that I have, I don't find any results. Category, I don't find any results. And so overall, the assessments give some recommendation for example, person, try to reuse core person vocabulary and properties. For address, try to reuse it from core location vocabulary. For event, core public event. And in the same way, if you want to just check one class, you can have a similar analysis done. Is person interoperable to the class person in core person vocabulary? Again, reflecting on an appropriate plan to do, and then executing it, looking into core person, checking if there is interoperability between the two. So for the moment, this is still an early version. You see that in terms of the plan, it makes sense, the different steps that he proposed, but we still could fine-tune it to be more clear in terms of criteria. And so step by step, by giving it more information, we could reach out that type of information and ensure that when you provide a model, it can have a nice assessment and analysis. That's actually what are we doing in terms of next steps. We have the basis that's created, but now we can still enrich it with additional tools that could be used to perform other use cases. I talked about the interoperability assessment or interoperability checks. That's one thing that we are exploring. You can also have the prediction of semantic tags. That's another proof of concept on which Semik has been working. The prediction of semantic alignments between two data models, or we could even think of a generation of a first version or a first draft of a semantic model based on a set of requirements or use cases. And I think that was the last slide. Don't hesitate if you have any question.
Great, many thanks. So we have a whole lot of questions that have come in via Slido, but let me check quick first. Do we have any questions here in the room? Yes, in the back there.
Hello. Thank you for the tool and the presentation. I want to know if the AI assistant is able to know that my class or concept is deprecated. So like when we're asking if to use person, does it know that the semantic somewhere, that class was deprecated or no? That kind of thing?
That's a good question. It's a bit always, is the information available in your data model? That's going to be the basics for the AI to be able to answer properly to that type of question.
Because in LOV,
yes,
in LOV you have that information encoded in OWL. So I don't know if it's able to extract that information.
Then yes, because in the index where we have the different data models, we try to keep as many of the metadata available into the LOV graph available. Maybe for some information is lost, but that's also why we want to explore the graph rag part, so directly querying the graph, so we are sure we have all the information available about the data model, the concept, and so on.
Okay, so the first question from Slido is from Marcel. The question is, does the assistant look at the commitments of the ontology as a whole that they look up in order to check it, or is a picked entity looked at and evaluated in isolation?
So in the way we design the tool, the data model is provided fully into the prompt of the LLM. So it takes the model into its all. Now, we are also looking at, in the development that we are doing at the moment, in ways of rather taking subparts of the data model to make some analysis, also in terms of, performance, efficiency of the query, not being always forced to put everything into the prompt, even though by doing this, we might lose part of the information. So that's kind of the trade-off that we still need to evaluate and see where we need to stop.
Okay, next question. Are you considering connectors to ontology repositories, such as EMBL EBI ontology lookup service?
That's not something we thought about. For the moment, we really focused on this small subset as we were working mainly on a POC. But indeed, it would be interesting. I think one of the idea that we have, and also still in this idea of having a graph query part, is to be able to connect to different Sparkle endpoints, to be able to have access to a richer set of standards and data models. So it's somewhere in a space of our heads, but at the moment it's not yet the plan, but clearly.
Okay, next question is from Wouter Vandenberg. If this uses MCP, can I hook this up to my coding agent, e.g. Claude Code, and work with this in my integrated development environment, IDE?
So for the moment, both the MCP server and client it's still a POC. It's a bit the same as this morning, so it's not made available as is. So theoretically, if we would release it, you should be able to use it as it uses MCP. But at the moment, we still keep it internally since, it's still in development phase.
Yeah, I mean, it's also because we cannot, I mean, as you say, it's a POC, so we have a limited resource. We're not working on a powerful machine. And it means that if when we will put it outside, so we can, I mean, I would say for case by case if people are interested to have people to test it. So this is something. So you write to Digit Semic team. Maybe I could add as well, I mean, what you were mentioning, I mean, to connect to repository. There is also a presentation on another project we're working on, which is the semantic, the registry of semantic models. Is it this tomorrow? So tomorrow with Claudio is here. So I mean, this will be also, I mean, we're trying to do a registry. Instead of having also the chatbot connecting to every registry, we would take this, to every repository. We will have this registry, it would connect to, qualified sources. And so it could, be the source for the chatbot, of course.
Great. Well, lots more Slido questions that we don't have time for, I'm afraid. But if any of the questions came from people in the room, I'm sure you can grab Emilien and George in the coffee break. How about another round of applause for them?